Welcome back to Muddy Math, where we take middle school math concepts that are a little muddy and clear them up. My name's Sam, and I'm here to help you create a math journey that you're proud of and that you enjoy, something you can come back to regularly. Math has a layer of negativity all around this world, and I'm here to help you pull off those layers of negativity and start building up these beautiful layers of enjoyment and delight. Today we're going to be completing the Circles at Home activity. Download your copy of the PDF enhancement in the links below. Here are some really important words you need to know: center, circumference, diameter, radius, pi, irrational, and rational approximation. Join me in my backyard as I measure circular objects to see if I can find the ratio of pi. I'm choosing this wagon wheel because I can identify exactly where the center of the circle is, because the diameter of a circle has got to go through the center. So the diameter seems to be 20 centimeters and the circumference looks like 63.6. The next circle I'm going to measure is the cross section of an orange. Now an orange is spherical, so the cross section is going to be a circle, and I'm going to measure this time with inches. So the circumference, the distance around the circle, sort of like the perimeter, is 8 1/8 of an inch, and the diameter is 2.5 inches. So you see that my inches here are broken into eighths. Sometimes inches are broken into sixteenths, but there's 1, 2, 3, 4. Halfway mark is the 4, so 5, 6, 7, 8. These are eighths, and the circumference of the orange came to the first notch, which is 8 1/8. The next object I'm going to measure is this wheel, sort of on my dog run. It's a pulley system, a wheel. Looks like it's 6 centimeters exactly in diameter, and it looks like it's 20.1 centimeters. Now the pulley was a little difficult to measure the circumference because my tape measure had to go around the metal clasp that connects the wheel to the dog run. So in this case, maybe having a string would be better, and I could thread the needle of the string through that metal attachment and get a better accurate reading of what the circumference is. So it's something to consider what you're measuring with and how precise it's going to be, and being okay with any errors that occur, because we're human and we're going to make errors, and these are estimated measurements. So here I've got an old dryer drum. Finding the diameter of this drum is going to be a bit more difficult because it's a cylinder and there's no base. No top base or bottom base for me to identify where the center is. So I'm going to have to estimate. So this looks like it's 25 inches and 1/8 of an inch in diameter. And whatever I measure the diameter in, inches in this case, I want to do the same with the circumference. Plus 19 3/4. So 60 plus 19 3/4 is 79 3/4. I'm really not getting a good ratio here, so I'm going to measure the diameter again. Awesome. So I have a diameter of 25 1/4. So the diameter of the tree trunk, the center is right here. I can see right down that that's the center. The cool thing about trees is that they make yearly rings, so you can, every year that it grows, it makes a ring, so it definitely grows in a circular motion outward from the original baby's sapling. But anyway, the diameter looks like 18 3/10 of a centimeter. So what I'm going to do is find the ratio of circumference divided by diameter for all 5 of these measurements, and hopefully they'll all be really close to the value of pi, and pi is an irrational number, so I'm going to be considering a rational approximation of pi, which could be 22/7 or 3 14/100. Okay, so we're hitting the whiteboard to try to figure out if our circles that we measured in the yard have this ratio of pi when we divide the circumference by the diameter. Do these circles I found in my yard have this relationship that the diameter wraps around the circle's circumference about 3 times? Pi is approximated to be 3.14, so it's basically 3 and a little bit. So let's see if the objects I thought were circular in my yard actually have that. Now remember, I measured it, so there's going to be a little bit of error. So for that reason, I'm going to round to the nearest tenths place. That's 1 place value after the decimal. So my wagon wheel was really nice because I could identify that center. Okay, the center is very important because the diameter crosses through the center of a circle. And in cases like this, I don't know where that center is. So I'm guessing that's creating more error in my measurements. So with the wheel, the orange, and the other wheel, I'm really lucky because there was a mark showing me where about the center was. The tree had a little bit of a mark, but my slice wasn't a perfect cross-section like the orange, so this one should have some error as well because, one, the tree might not actually be a circle since it's grown from nature and isn't as circular as orange typically is, but also it was cut with an axe, so it's kind of jagged. But without further... So here we go. The ratio of the circumference to the diameter we're hoping turns out to be close to pi, which is about, and I use these squiggly equal signs to show about equal to 3.14. Now remember, I'm going to be rounding all of my ratio values to the tenths place. So if I round pi to the tenths place, that's about 3.1. So 310% of the diameter is the circumference. Let's see if that works. So the ratio of circumference to diameter for my wagon wheel is 63.6 over 20. Now I anticipate this to be very close to pi because I know that 20 goes into 60 3 times. So I have this value of 3, and then I have 3.6 over 20 left over. So what is 3.6 divided by 20? Well, I can use long division, but to save myself some effort, currently my practice right now, I don't want to practice my long division. If you are practicing long division, dive right in, but I'm going to use a calculator. 3.6 divided by 20 is 1800ths. So really right here I have 3 and 1800ths, but remember I'm rounding to the tenths place. So this is going to go ahead and round up to 3.2. So my first ratio of circumference to diameter has an approximate value of 3 and 2/10, meaning that for my wagon wheel, it seems like the diameter wraps around the circumference 3.2 times. Pretty close to pi. All right, let's keep going. 8 and an 8 divided by 2.5. So quickly, I can do 8 and an 8 is the same as 65/8 divided by 5/2. And with that, I can change this to a multiplication expression because a division expression is the same as a multiplication expression except the divisor needs to be reciprocated. So 65/8 times 2/5. I can do some cross canceling here. I like this. I like the looks of this setup. 2/8 is the same as 1/4. And 65/5 is the same as 13 over 1. So we end up with 13/4, which is really 4, 8, 12, 3, and 1/4, which is 3.25. And we're rounding to the nearest tenths place. So my approximate value here is 3.3. Continuing on, we still have not seen any of my circular measurements hit pi exactly. But remember, I'm measuring with a measuring tape, and there's going to be room for error because I'm only human. I am powerfully human, I guess. Okay, so continuing on, 21 and 1/10 divided by 6. 6 goes into 18 3 times, so then I get 3 wholes with 18 from 21 is 3.1 over 6. So looking at it as a mixed number, I know that 3 divided by 6 is 1/2, and this is going to be greater than a half. So this is about 3.5 using my reasoning. Let's just check what 3.1 divided by 6 is, and we get 0.516 continuous. So I'm happy with this approximate value of 3.5. 29 3/4 divided by 25 1/4. So to use my calculator, I can either type in 79 plus 3 divided by 4, and then divide that by 25 plus 1 divided by 4. Or I can convert these to decimals, which is what I'm going to do because it's less buttons to press. 79.75 divided by 25.25. Okay, I'm going to estimate that this is, before looking at the numbers, I would think that my drum would be the measurements with the most error because there's no center mark and it's really big. I had to wrap my measuring tape around it twice. I had to hold the place. I think the most error is going to be here. What do you think? 3.15. Wow. So this is 3.158, so I'm going to round the hundredths place up to a 6, which is closer than the 3.18. However, I said in the beginning I'm rounding to the nearest tenth. So using that significance of the tenths place, we really didn't get any closer than we already were with the wagon wheel. But in my heart, I'm really impressed with the measurements of my drum because that was a tricky one to measure. And last but not least, the tree trunk. So 62.8 divided by 18.3. I know 18.3, well, that's about 20. 20 times 3 is about 60, so it looks like we're in the right ballpark here. 62.8 divided by 18.3 is 3.43. So all of my measurements had the diameter wrapping around the circumference more than we would have anticipated. We typically expect with a perfect circle for the diameter to wrap around the circumference 3.1 times. In these cases, we had it wrapping around more than that, but I'm pretty happy with these results. Now, which of these numbers, if any of these numbers, well, since it goes 3.2, 3.3, 3.4, 3.5, which is the best measure to represent my data? 3.2 occurs twice in my data. That's called the mode. Is the mode the best measure of center? Best measure of typical for this data set? Let's do a quick one-dimensional plot on a number line to see if visually it does look like the best measure of center, and then we'll go from there. The population of circles that I measured in my yard range from 3.2 to 3.5. I have two values that are 3.2, one value that's 3.3, one that's 3.4, and one that's 3.5. When I look at this dot plot, I see that there's no symmetry here. It's called skewed right because my peak of the data is here, and if it was symmetric, I would have points to the left and the right of the peak. But in this case, I only have points to the right. So the visual observation of a dot plot is the first step in determining which measure of center best represents my data. I know the mode, the most common, is 3.2. My median is the middle number, so I have 5 data points. The middle number is 3.3 because I have 2 to the left and 2 to the right of 3.3. So my median is 3.3. Now my mean relies on the actual values of my data points. The mode is just the most common. It doesn't recognize the value of each data point. It just recognizes the frequency, the most frequent number that pops up. The median doesn't rely on frequency or on values of the numbers. It relies on the order. So from order from least to greatest, what's the middle? It's 3.3. and we're looking at the data points there. So there's 5 data points, it's the third, it's the middle one. The mean, however, requires you to use the values of the data set. So we need to find the sum of all of them and then divide by how many there are. And there are 5. So we get 16 6/10 divided by 5. So you'll notice that the mean is greater than the median because the data is skewed right. And it's typical of skewed right data to have a median that is less than the mean because this maximum value added into the sum of the values pulls that sum higher than it would if all the values were closer to the median. So for example, if this one didn't exist and we had 3.4 instead of 3.5, we had 2 3.4 values. Okay, this would change everything because now we have another peak in the data. But then that would give us 15.6. That would give us 16.5, and that would be exactly 3.3. So it's not the case. The case is that we have a maximum of 3.5 and that our mean is greater than the median. I would say that the mode does not accurately represent the values that are to the right of our data, the greater values, and that the mean is close enough to the median that we can rely on the rule that if the data is skewed, we will stick with the median because we don't want the values of the extreme numbers to affect the measure of center. So to me, 3.3 seems like a good approximate value of the ratios from circumference to diameter that I found in my yard. 3.3, how far off was I from the expected? So really quickly, 3.1 minus 3.3 tells me that I'm 2/10 off of what of pi? 3.1. So 2/10 divided by 3.1 is 6%. So my error is about 6% off, and I'm pretty happy with that. Please, I encourage you to try to find objects that are circular. Just like my tree trunk, it wasn't a perfect circle, but give it a shot. See if it has that relationship or close to it. Check out my YouTube channel, Muddy Math, for more inspiring activities, exercises, practices, and considerations that you can infuse into your math practice. From my heart to yours, thank you for showing up, and I'll see you next time.